Stop talking, please. We are continuing with greatest common factor and least common multiple. So the first thing I want you to do is review prime factorization. You are going to do the factor trees for each of these numbers and then write the prime factorization. Any questions? You have about 4 minutes. Go for it. 21. Can 2 go into 21? 3.
Yes.
So 3 times what?
7.
Both of those are prime numbers, so we are done. And our prime factorization is 3 times 7. All right, 30. Can 2 go into 30?
Yes.
How many times?
15.
2 is a prime number, so I circle it. I can keep going with 15. What makes 15? Can 2 go into it?
No.
3?
Yes.
3 times
5.
Both of those are prime numbers, so I get 2 times 3 times 5. 42. Can 2 go into it?
Yes.
2 times?
21.
2 is a prime number, so I circle it. Can 2 go into 21?
No.
3. 3 times? And those are both prime. So my answer is 2 times 3 times 7. And 19. Can 2 go into it? 3, 5, 7. No, it is already prime. So what are its two factors? 1 and 19. So 1 times 19. Any questions about that one? All right, let's turn the page. Yep.
And this gives us a great opportunity. Today's lesson is not super long, so I'm going to take just a minute to talk about an important concept. Have you guys noticed something about the problems that we have been doing so far in our book? About 80% of them are word problems. Okay? That's the way our new curriculum is designed. So for you guys to be able to understand and break down the problems mathematically, we have an avid strategy that works really well for doing it. It's called marking the text. So I want you guys to box off about half of this first problem space and talk about marking the text. Okay? Marking the text is 3 simple steps that helps you to break these word problems down mathematically and to be able to get the correct answer. But I've seen several of you, as I'm checking my homework today, in last class, you guys have all of the work to answer the question, but you're not paying attention to the question that's being asked. It goes all the way back to our second day together, where we gave you that directions test. We talked about the importance of following directions, right? You guys remember that? Okay? If I ask you to use distributed property, but then you use order of operations to solve the problem, did you follow directions? No. Even though you have the right answer, you get more credit? No, because you did not do the process they asked. So here's what marking the text consists of. It's really actually pretty nice. And you can do all of this at once as you read it. So it shouldn't take you a whole lot of time because you're reading the text anyway. Step 1. What we're going to do is circle numbers and units. Mostly because in math, numbers and units are really what we work with. So those are going to be some of the most important pieces of the information we gather. I will add a caveat, especially in standardized testing. One thing they love to do is throw numbers into the problems that are irrelevant. You don't need it all. Because it really helps delineate the students to understand what they're doing and what we're just plugging a bunch of numbers in to try to solve something. Step 2, we're going to underline math terms. So here's where our vocabulary comes back in. Again, you have to really understand what it is that we're doing. And if you don't understand the terminology, it's going to be very difficult for you to do the problem properly. By underlining the math terms, that's going to be kind of your hint as to some of the things you're doing to solve the problem. And probably the most critical of all of them is step number 3. Number 3, we are going to box the question and or the direction. And really, when it comes down to it, that's the key. Once you've got your answer, you need to make sure that answers that question that is boxed or the direction that is boxed. Because if you have an answer that doesn't actually answer it, you really haven't answered the question, have you? Okay? Now, another slight note. We're seeing so many word problems. When we are doing word problems, our answer must be full sentence. Normally, box the question, that's your starter for your answer. Okay? So, let's practice this real quick. Just using our directions right here at the top. You can solve real-world problems that involve common factors or common multiples by thinking about the question you are trying to answer. Consider each scenario. Determine whether you would use either a common factor or a common multiple to solve the problem. So here's what we're doing. Deciding, do I need a common factor or a common multiple to solve the problem? Ooh, look at this. They even put it in bold for us. Explain your reasoning. Do you think that's important? Yes. It's actually the most important part of the problem we're doing on this page. So, from our direction, we need to do any math on any of these problems. No. Why would you say no? You're in math class. You think you don't need any math to solve the problem. That's what I thought. So you're sticking with your no? So you go, yes. You need that math. You need to show math on the problem. I wish you would have stuck with your gun. Guys, what we just did is an example of what I will often do with you. Very psychological. You need to be confident in your answer and defend it. You were right. We don't need any math on this, guys. All I'm doing is I'm just saying, do I need a common factor or a common multiple to solve the problem? Okay? No, that's it. Not a yes/no question. That's what you're doing. And then you need to explain why. So I'm going to mark the text on the first one with you guys to help you get that concept. But understand, you're not doing any math on this page. All you're doing is marking your text, reading the problem, and determining, am I finding, and I'll make it even easier for you, am I finding GCF or am I finding LCM? Okay? So, number 1, hot dogs come in packs of 8, hot dog buns come in packs of 6. What is the least number of hot dogs packs that you can buy when you want to have the same number of hot dogs and buns? So here's our question. What is the least number of hot dog packs you can buy to have the same number? So do I actually need to work that out? Figure out how many hot dog packs I need? No. You need to take this information, tell me, am I going to be finding GCF or the LCM? And tell me why you think that is. Does that make sense for everybody? Yes. Okay. So if we're not really doing math on this, we've only got 4 problems on this page. And all you're doing is marking your text and telling me, am I finding GCF or LCM, and why I'm finding that. So we'll give you guys about 8 minutes to do these problems. Want to get started? Try to work on this by yourself. Once your whole table is finished, all 4 problems, then you can talk about it amongst yourselves. You have 8 minutes again. Okay, guys, on this first one, the key word that they said, what is the least number of packs I could buy? Is that going to be a GCF or an LCM? I'm looking to break them down, or I'm multiplying out until I find the same number. LCM, I'm multiplying out until I find the right number. Okay, LCM. I need to find the first time They are equal. That's what LCM is all about. If I'm taking the numbers out to find the first occurrence when they're together. Lev has 36 pencils and 25 erasers. He wants to use all of the pencils and erasers to make identical packages for a friend. What is the greatest number of packages that he can make? Am I breaking these down or am I moving them out? Get one in common. Okay? Okay? GCF. Why do you say GCF? Somebody say LCM? Does everybody go with GCF? Yeah. Okay, so everybody knows why. Why? Tell me why. Okay? Good. So breaking it down, right? Breaking it down. The number of packages. Make sense? Okay. Number 3. There are 40 sixth graders and 24 seventh graders in after-school programs. Becker wants to create groups where each group has the same number of sixth graders and each group has the same number of seventh graders. What is the greatest number of groups she can make? Yeah. What do you say, GCF? GCF, because it's breaking into groups. Breaking the numbers down and then set their groups, that's going to be a GCF. And I'm finding where they meet, that's an LCM. So every time Soraya babysits, she saves $12 of her earnings. Every time Aaron babysits, he saves $5 of his earnings. After babysitting a number of times, Soraya and Aaron have saved the exact same amount of earnings. What is the least possible amount of savings they could each have? Yeah. Good, LCM. Looking for least amount where they meet. Okay, so conceptually, are you guys seeing the difference between GCF and LCM? Okay? Once you understand that difference, that's going to help you to solve these problems because you'll know which one you need. The nice thing is, using the cake method, we have both of those numbers right at our disposal. So really, it's just, that's why this exercise is so important because it's understanding which of those two that I actually need to solve the problem. Any questions on this page? Okay, let's go ahead and turn the page. No, we're not doing homework yet. We're on page 29. Okay, consider each situation. Solve each using either the greatest common factor or least common multiple. Emily has 3 bags of different types of beads. She wants to split up the beads into mixed packages to share with her friends. She wants each package to have exactly the same number of each type of bead with no beads left over. Okay? So, what is the greatest number of packages that Emily can assemble? There's our question. Describe the collection of beads in each package. So, is there one part or 2 parts to this question? 2. Okay? I'll go through the marking and the text on the next one with you as well. A cyclist completes a lap around the track in 12 minutes. A second cyclist completes a lap around the same track in 18 minutes. If both riders begin at the starting line at the same time, maintain their speed, after how many minutes what we need again at the starting line. So there's our question. There's another important part there though, right? When you're reasoning. So both of these questions have two parts. So now do we need to do the math? Yes. Now they're asking for answers. So we're doing that next step. So and just for the record, they give you the counts here for the first problem. So that's where your numbers are. Questions on what you're doing on this page. Okay, we'll give you guys about 7 minutes. Go ahead and answer these two questions.
All right, so what are we finding for number one? GCF, greatest common factor, and that means we are still doing the cake, guys. That has not changed since last class. I'm not sure why everybody was so confused. Can 2 go into all three numbers? Yes. 2 goes into 40 20 times, into 72 36 times, and into 24 12 times. Why am I talking over somebody? Can 2 go into all of those numbers? 2 goes into 20 10 times, into 36 18 times, and into 12 6 times. Can 2 go into all three of those numbers? 2 goes into 10 5 times, 8 9 times, and 6 3 times. Can 2 go into all of those numbers? 30 5 7. Okay, so here's where we would do the glass ceiling and keep going, because can 3 go into 2 of those numbers? Yes, but that is only if we are finding what? Least common multiple. Are we finding least common multiple? No, so we can stop here. What is 2 times 2? 4 times 2. 8. So my GCF is 8. And how many will be left in each bag? Yes, the spacers will have 5 beads left. The brown beads will have 9 beads left. And the rectangular beads three beads left. Any questions? It should not have been a surprise what you were using to find the GCF or LCM, guys. We're not trying to trick you. Yes? You're not putting the leftovers anywhere. That's just how many bags will have left. Those are the ones that won't fit into a box. Like this. You have 8 complete boxes with the same number of beads in each box. And then you have the leftovers over here that don't fit. Okay. All right, so what are we finding for number 2? The least common multiple. They are multiplying how many minutes they will have to go through until they meet up again. So we're doing 12 minutes and 18 minutes. Can 2 go in each of those? So 6 and 9. Can 2 go in each of those? 3. So that's 2 and 3. Can 2 go in each of those? 3, 5, 7. So we're done. 2 times 3 is? 6 times 2 is? 12 times 3 is? So LCM is 36. They will meet after 36 minutes. Any questions about that?
Okay, guys, let's go ahead and turn up. Yes, question? So they'll meet after 36 minutes. You're saying because it doesn't explain your reasoning. So yes, in a case like this, your work can show your reason. Okay? Yes? Okay. Question came in on this last problem here, guys. In our directions, it said there were no beats left over, right? So all we're saying is, slight misinterpretation. So this is described the collection of beads in each package. So it's not left, this is how much is in each package. So there's 5 spacers, there are 9 round beads, and 3 rectangular beads in each package. There's not much left. This is how many of each of those is in those beads. Make sense? Okay. Mr. Chan's not feeling at the top of her game today, so excuse her on that. Yeah, the rain actually really does mess with her. She got a lot of people. You need to know that. Okay, we're gonna go back to the problems we just did. So 2 pages ago, you determined, do I need to find GCF or LCM? Now we want you to answer the question. Now we're going to do the math for it. So you can look back, and just to help you guys, I'll say this one's got a little marker text to figure out what you need to answer on this. But on this one, you were finding LCM. On this one, we were finding GCF. On this one, you were finding GCF. And on this one, you were finding LCM. So now we want you to actually do the math and answer the question. So we've only got 17 minutes left in class. So we will give you guys 7 minutes to do this. I'll give you 3 minutes to do it. Show you the answers. Then we'll go over the homework. Okay, so you have 7 minutes, almost 2 minutes per problem. Well, I've already told you what you need to find. Use the numbers and find the answers. Make sure you're answering the question and ask those. That's all you have to give you, other than marking your text will help you figure that out. Okay, guys, I've only got 2 minutes to get through this so we can get to the homework. I apologize in advance, I'm going quick. So we're revisiting and solve each one using GCF and LCM. We already made a note on which we're doing. Hot dogs come in packs of 8. Hot dog buns come in packs of 6. What is the least number of hot dog packs you can buy? We have the same number of hot dogs and buns. So I have 6 and 8. Divide those by 2, gives me a 3 and a 4. I'm done there. I need my LCM, so I'm multiplying all of them. 3 times 3 is 6 times 4 is 24. So my question was, what's the least number of hot dog packs I could buy? So I'm buying 24 hot dogs, and hot dogs come in packs of 8. How many packs should I buy? 3. So you need 3 packs of hot dogs. Again, the importance of reading the question. If you did all that work and answered 24, were you correct? No, you were not. Because you didn't answer the question that was asked. Okay, Zed has 30 pencils, 40 small erasers. You want to use all the pencils and erasers that make identical packages for friends. What is the greatest number of packages you can make? 36, 45. Can I divide both those by 2? No, by 3? Yeah, gives me 12 and 15. Can I divide those by 2? By 3? Yes, I do another layer. Gives me 4 and a 5. 4 is one of 5 is like the others. Let's go to 4 if I'm done. GCF is on the left. 3 times 3 gives me 9. So we can make 9 packages. They didn't ask it, but had they asked how many pencils and how many erasers are in each, that's right on top. So it has 4 pencils and 5 erasers in each package. So all those numbers do mean something. There are 46 graders and 24 seventh graders in that school program. They want to create groups where each group has the same number of sixth graders and each group has the same number of seventh graders. What is the greatest number of groups she can make? So I've got 40 and 24. Can I divide those by 2? Yes. It's going to be 20 and 12. Can I divide those by 2? Yes. It's going to be 10 and 6. Can I divide those by 2? Yes. It's going to be 5 and 3. GCF is on the left. 2 times 2 is 4. 4 times 2 is 8. So my GCF is 8. You can make 8 groups. They didn't ask it, but I could have said in each group you will have 5 sixth graders and 3 seventh graders. Are you going to see where all these numbers come together? Okay. Every time Soraya babysits, she saves $12 of her earnings. Every time Aaron babysits, he saves $9 of his earnings. After babysitting a number of times, Soraya and Aaron have saved the exact same amount of earnings. What is the least possible amount of savings they could each have? So I've got 9 and 12. Can I divide those both by 2? By 3. Yes. 3 and 4. I need LCM, so I'm multiplying all of them. 3 times 3 is 9. 9 times 4 is 36. So they will each have $36 and the amount each. For a time. Does that make sense? Okay, so unfortunately, we do need to get to the homework. Go ahead and turn to page 31. I have several notes on here that are going to be very important for you to write down. So clear this out and write these notes on there. Your journal should be relatively easy. You're just writing a definition in your own words. So kind of use your own words. Tell me what you mean. Here's where it gets a little more interesting. You need to read and solve each problem. So if you mark your text, you're going to see something very interesting on this problem. I've got different machines. The first does a part every 12 seconds. The second does a part every 45 seconds. They test each time they both come out of the machines at the same time. How often does she test the part? Show your work and express your answer in minutes. Okay, I'm pointing it out. Make sure you don't do it right. I'll give you a hint on this. You're looking for LCM. Number 2, he's got 56 9-year-olds, 42 10-year-olds, and he wants to divide the group into basketball teams. Okay, how many different ways can he divide the group? We're going to change that a little bit and just say, find the GCF. You don't have to tell me all the ways, but show me how many you put on each team with the most teams. So that'll tell you the greatest number of teams. But then part C is a thinking one. Hopefully you understand basketball. If you don't, you can research a little bit. Or look at the number of people on each team and tell me, does that make sense that that's the way you should do it? Number 3, here is another one. They're checking it every 15 minutes. But they've got 12 seconds, 30 seconds, and 36 seconds. So list the time in minutes that he will check all 3 experiments. So you're finding LCM. Problem is they've given you in seconds, and I need my answers in minutes. Students in our class have a blue cloth, 60 inches, gold cloth, 48 inches, and white cloth, 72 inches. We want to cut all the cloth in pieces of equal length. What is the greatest possible length of the pieces? Not have any left over. So on this one, we're looking for a GCF. And then how many pieces of each color? That will be that top line once you're finished. Boxes that are 16 inches tall are being stacked. Boxes that are 20 inches tall. What is the shortest height at which 2 stacks will be the same height? And how many boxes will be in each stack? So again, on this one, we're looking for LCM. And that top line is going to tell you how many boxes are in each stack. Yep, that's why we have a video for it. Okay, so this will be on the video. We got 1 minute left. So if you didn't catch marking of the text or what you were trying to find, tonight, we have cut next period, so we'll put this up. Don't forget we have open house tonight as well.